Okay, so let's do some more surgery on this thing and see what we can get it to do. I thought at first of all I'd try to replace that motor that causes rotation with something that causes it to go in a direction. But first I want to demonstrate a way that things can go wrong. You've got to watch out for some of this stuff. Now, let's say I put a motor on the thing and I went top to bottom, but I did it diagonally. Okay. So now that thing's pivoted a little bit. If I click on joint connector, I connect them up and hit play. It kind of squirms, but it doesn't go anywhere, and that's because it's colliding with the floor that's underneath it. So that's why it's not working. Let's get that out of there. Gotta watch out for stuff like that. You can always change it later. You can put on a new one or move it around or something like that. But you do have to worry about things going wrong that way. Next, I'm going to try a piston. I'm going to make this thing move. We'll do a few things that are more sophisticated as we go along. Some of them I'm still struggling with. And then there's always the option of like making a joint move another joint, which can get you some strange results. But let's start with the piston. And remember I said with pistons, it's not only the direction, it is the length. That length distance there is important. That's how far our object is going to move. And we'll say joint connector, you click on the piston, hold down control, left control, click on the object and hit play. Boom. And now you get a perfectly even movement, which it jumps forward, but it doesn't keep moving. It stops right there. Let's take a look at something else. Let's select that piston real quick and go look on the user interface for it. Now you can see some of the rules that it's following. So here we have piston 10379, that's its name right there, and it is connected to this object, which if you select the object instead, it'll show you that that red cube is connected to piston 10379. Okay, let's back over here to piston 10379. Its minimum is 0, its maximum is 150, so that's how far out it comes. Its acceleration is 40, which is how fast it moves, and then its damp is 10. That's its resistance. Let's cut the damp down a little bit and see what happens. Boom. So now the resistance takes a little bit longer to slow it down to a stop. You can cut that down real far, and then you get sometimes you get some really weird results. Like if you set it to -1. Which is entertaining, but it does seem to be going much farther than it should be, and eventually it'll yeah, there it goes, starts knocking stuff around and really goes quite berserk on us. So yeah, you can see how that's not really doing what we want. The damp and the acceleration all work in tandem with the density of the object, so if I kick the density up really high, we should get different results. So that -1 is having trouble overcoming that. It's pushing a little bit harder. It's increasing the amount proportionally as we go along. But let's try 22. There you go. So if you balance out the numbers, and I haven't found a perfect formula for it yet, you can get the thing to just stay in a static line, or you can just build something for it to run into, like a wall, which has been set to static mesh. Notice I have that selected there. Static mesh will not move, even when things run into it, and then the things can't push through it either. Let's try kicking that up really high. Let's take that piston and give it like 120 acceleration and see what happens. Oh, still nothing. Okay, well, we'll figure that out later. For now, let's make a piston so I can check off that you did it. And maybe we'll examine some of the other things too after that.